So today I'll be going over some of the code that we used on the Group 5 code demo. We did the initial presentation a few days ago, but it just came to our attention that we forgot to include this. So a lot of this code that we're going to be looking at is just building the GUI, or the graphical user interface, which, because of my inability to understand J-frame, I just never had the opportunity to learn it. We're going to be skipping a lot of, if I can get it selected properly, this code right here. All this code here, it's not necessarily functional as far as what the purpose of this program is. It's just to build the GUI. This could be all removed and this program would still work in a console window, such as command prompt. But it's a lot easier to present when given a GUI. So now this code, like I said, is not necessarily functional, so I won't be necessarily going over this. I will be going over the functional part of the data. So here we have table data. So this is a two-dimensional array where one column is going to be IP addresses, which are going to be these here. Now this one's default, and I'll get into that in a minute. And then you have the name of the host at that IP address. So if you think about your physical address, you live at your physical address. So you think of this being your physical, or your mailing address, and then this would be your name as an example. So every node on the network has a name and it has an IP address. So here we have interface 0, 1, then we have a router, then we have router 2 as the default. So when you're looking at different gateways and paths that IP traffic can navigate, here, I'll save that. It has a set path predetermined by the network overall. Now, this predetermined path takes an input IP address, and if it matches a certain pattern, it sends it along a certain path. Now, say the input IP address doesn't match any of those. That's what the default is to handle any traffic that doesn't match any previous pattern. So here we have a table being built where it's combining the data here, and that's just some more GUI stuff right there. These two methods here are just for setting what the next destination or the next hop would be. Here we have 4 different octets, and what this is, we have integer variables here set to input some dialogue from the user, and I'll show you in just a moment. But this is where it's going to ask for an input IP address. And then here it combines it into a single string that is called IP address. So there were 4 octets that's going to ask for the user. So when you initially run the program, it's going to ask for a first octet. So we're going to do, for an example, 192, and that's going to be the first quarter of the IP address. And then let's say 168.1.1. Up here, you'll see that IP address 1 octet, 2nd octet, 3rd, and then 4th. So we get that data from the user in a series of 4 different text windows. Here we have a decision structure used to determine, based on the information given, whether or not it matches a certain pattern or not. So up in this table, we have 2 entries that start with 135. The 2nd octet on both entries is also 46. The 3rd octet is where we differ. So we have 56 on interface 0 and 60 on interface 1. So here it's asking if the first octet is 135, if the second is 46. Then it asks if the IP address, the 3rd octet, is between 56 and 59. Because here's where we have, the first octet being a 135, and then the second one being 46, because this is a class B address, the last two octets are part of the host. So this is where we get a little more lenient per se. So it can be anywhere between 56 and 59. If it is between those for the third octet, it'll send it to interface 0, regardless of what the last octet is, because here's where we have the final decision. And then if it's over 60 and less than 63, then we send it to interface 1. Otherwise, we send it to router 2. So you remember that default earlier, it doesn't match a pattern. It'll send it to router 2 if it doesn't match 135.46, and then it doesn't break down to either anywhere between 56 and 59 or 60 and 63. If it does start with 135, but it doesn't have a second octet of 46, then we're going to send it to the default gateway, or which is router 2 in this instance. Now, if it starts with a 192, then the second octet, given our set decision structure up here, is going to be 53. Then we have the third octet is 40. So octet 3 can be greater than or equal to 40 or less than or equal to 41. So it's either going to be 40 or 41. If it is, send it to router 1. If it isn't, send it to router 2. If the second octet is not 53, send it to router 2. If the first octet is neither 135 nor 192, go ahead and send it to the default gateway because it doesn't match any of the previously defined patterns. Here's all this code that I mentioned is for the GUI. I don't understand JavaFX, JSwing, or anything like that, so I can't necessarily explain what any of this does. However, we do have a list box, and this is where we add the IP address previously entered by the user earlier into that list box. When you choose the item in that list box, we have an action listener. So when the user clicks on that item in the list box to otherwise select that item, it'll then set the IP address that we're going to be using in the code to the one that the user selected in case there's a list of IP addresses. And you'll see it gets next hop, and it also fills out the GUI with all the information that it needs, and I'll show you in just a moment. Then you have adding to the panel, and then repaint. Again, GUI stuff that I'm not necessarily sure of. Then we have the main method. This just runs the program and edits some of the GUI code as well. So I'm going to go ahead and run it, and I'll try 2 different IP addresses. So, oops, lost that window. There we go. So we have 135.46. Now remember, we have 2 choices that are 135.46. The third octet is where it matters. So anywhere between 56 and 59 will be interface 0. Anything between 60 and 63 will be interface 1. So for example, I'm going to put 58 for the third octet. And then I can put any number here. There is some input formatting that I could do that would limit it to 3 digits. However, let's just say I'm doing 1. Say it's the first item on that thing. So here's that list box, and when I click this item here, what it's going to do is going to populate all of this information. So there you go. There's the IP address that I entered prior and the interface that it would go to. So we're sending it to interface 0 because it matches 135.46, and then remember 56 to 59. So I entered 58, it matches that range, so it's going to go to interface 0. If I had entered 13546, or any number between 60 and 63, dot any number would send to interface 1, and that would show interface 1 here. Now, let's enter an IP address that's not considered. That wouldn't match any of the previously defined patterns. Let's see, 192.168.1.1. So this is the current IP address of my computer on my private home network. So this is not an address that you would see when referring to a website or a node on a network that's outside of your home network. So this is going to go to router 2, which if you remember is our default gateway, and that's because it doesn't match 192.53. So I have 168 in the second octet, so it doesn't match in any way, so it's going to send to the default. If this was 53 and the third octet was 40 or 41, it would have went to router 1. Since it's not, it did go to the default gateway. And this is just a way of mitigating traffic. So when you have a lot of traffic going to one destination, you can kind of set different paths in order to filter traffic through. So kind of keep things moving. Kind of like how we have lanes of traffic. If we were to lose one lane, we still have 2 or 3 lanes on the highway kind of thing for traffic to keep going through. All right, and that concludes my explanation of the code demo for Group 5. And that's it.